start to determine the molecular shape, you must memorize the molecular shape, type AXME, and okay, and then what the angle and what the name. Okay, you must know benda ni. So first thing first, you have to write the Lewis structure. Number 2, you assign the group. Who gonna be the central atom, who is the bonding, who is the non-bonding, and then you predict the bond angle and direction. Okay, is there any lone pair involved or not, and then you determine the name of the molecular shape based on the name here, and then you draw. Okay. Let's draw molecular shape, predict the bond angle. Okay, for example, PF3. Okay, PF3. So you have 3 brings electrons. So you can predict first. PF3 has 26 electron valence. Okay. Phosphorus is how much? Okay, phosphorus is 15, right? If I'm not mistaken. In the periodic table. Yes, phosphorus is 15. So fluorine is 9. So 9. Okay, 9 plus 15 is going to be 26 electron. Okay, so how you arrange? First thing first, you arrange. Okay, 1, 2, 3, 4, 5, and then fluorine 7 each. Okay, so 1 we bonded with phosphorus. So all together make sure 26. How do you know? So this is 6 times 3, so it's equal to 18, 18, 20, and then here bonding is 2 electron, 20, 22, 24, and 26. Okay, 22, 24, 26. Okay, so all complete 26. So if you have here, you can predict now that your structure is A. The center is A. X, you how many X you got? X is F. 1, 2, 3. AX3, and then N. Okay, EU. Okay, E for lone pair. Lone pair you ada berapa? Ada satu sahaja lone pair. So AX3 E. AX3 E, what is it? It's a tetrahedral arrangement. Okay, like that. AX3 E ada satu lone pair. So this one should have bonding less than 109. So this is has to memorize 109.5. Okay, due to repulsion of non-bonding. So we can call this is trigonal pyramidal. AX3E. So you must memorize AX3 is a trigonal pyramidal. Okay, right. Okay, the type of shape is AX3E, correct. Okay, so yes, that is how trigonal pyramidal should. So for COCl2, the same thing you have to do is the C has the lowest number of electron negativity. So C will be the center. So you rearrange. Okay, so how many electron? Carbon is 6. Okay, carbon is 6. 6 plus oxygen. Oxygen is 6 as well. 12. Okay, chlorine is 17. 7 lah. Right? So 17. How do we do that? Okay, so look at this one. Okay, so chlorine is 6 times by 3, 6, 12, 18, okay, 18, 19, 20, 21, 22, 23, 24. So this is how we predict the structure should be like that. So you just have A, center, and then X, how many X? Just AX3. Okay, dia tak ada lone pair. Alright, so you do not have C somehow. You do not fulfill the octet because C should be ada 4 carbon kan. Electron valence dia should be 4. So patut lagi ada lagi satu kat sini. Tapi dia tak boleh buat. So what we should do, 2 electron from here will donate to carbon to form the double bond. Satu akan make double bond lah. So macam mana? So dia akan jadi macam tu lah. Alright, so this is much more stable. This is called as incomplete octet. Okay, Alright, so then now you have complete that. Okay, so now we have still AX3 just with double bond. Alright, so this is trigonal planar. Alright, so trigonal planar all are have similar angle 120 each. Alright. Okay, so nearly lah. Okay, this one 124.5. So this one is 111. It's a bit ni sikit. Okay, less than due to the electron density of O. It's okay. Alright, if you draw macam ni pun dah acceptable. Alright. So predicting with 5 or 6 electron group, if you have like this SB 5 fluorine 5 or BR fluorine 5. So first thing first, draw the predicted. Okay, SbF5 it has 40 electrons. Ini you kena tambah sendiri. Okay, so kita count 6 times by 1 2 3 4 5 30 32 34 36 38 and 40. So cukup-cukup, tak ada yang elektron lompat. So kita panggil sini AX5. AX5 we predict that is trigonal pyramidal. Trigonal bipyramidal. So that is how the shape is. Okay, 90 and 120. 90, 120. Right. Okay, so that is the shape. Okay. So for BR53, BR54, BR fluorine 5, so it has 42 electron valence. You draw first, so you have 6 times by 1, 2, 3, 4, 5. So 6 times 5 is 30, 32, 34, 36, 38, 40. So means that you're going to have one lone pair. Okay, 40, 42, 42 electron now. Okay, so we're going to have one lone pair. So it's going to be 1A, X5, E. Satu saja E. EX5E. Shape is square pyramidal. So square pyramidal is like this. Kat atas tadi saja. Bawah ni adalah lone pair. Now you have to know, you know already how to use BSPR model to predict the geometry of the following molecule. So first thing first, draw the Lewis structure, find the arrangement of bonding pair, and then determine the geometry. So like this, ASH3, OF2, and AALCl4. Okay, you can do like that. So ini adalah A, X3, E. AX3E is trigonal pyramidal. Okay, then you know. Okay, this one is AX2. AX2 is the band. Okay, though is look at like a straight line, nanti you akan dapat band macam tu oksigen di sini. Okay, ini sebentuk band. And then ACl4. ACl4 is AX4. AX4 adalah tetrahedral. Okay, tetrahedral only. Okay, that's how we predict using the. Okay. For center like ethane or ethanol, okay, ethane is CH3, CH3. Okay, you have structure like this. One side of CH3, another side of CH3. Alright, so you may draw like that, like a seesaw. Alright, so this one, you have two lone pairs. So where it has two lone pairs is here, lone pairs. Alright, so we can say that this is ethanol, CH3, CH2, OH. This is how we draw based on the VS. Okay. So, predicting molecular shape with more than one central atom. Determine the shape around each of the central atom in acetone. Solution, first thing first, you try to draw who gonna be the center. Normally C lah. C double bond O gonna be the center. C double bond O, and then you have CH3 on one side. You have another CH3 on one side. Okay, so now this is tetrahedral. You have to predict one by one. Now one side is here is tetrahedral. Another side that is also tetrahedral. And then what happened to the CO? CO here. CO here is the trigonal planar. Because of what? Because of it has A, X, 2, E. Okay. Shape is A, X, 2, and then it have one lone pair. Okay. So that is trigonal planar. Alright. Okay. So if we have shape like this, so determine one by one as well. So we have CH3. Okay. So we have CO. Okay. That's how we draw. Okay. That's 100 triangular planar. Okay. So next is intermolecular forces. Intermolecular forces, a bonding force include ionic covalent or metallic bond. So covalent compound, either gas, volatile liquid or solid, have low melting point compared to ionic. So this property is due to weak intermolecular forces between the covalent compound. There are several types for non-bonding intermolecular forces, such as ion dipole, dipole-dipole, hydrogen bonding, dipole-induced, and force. Okay, so look at this one. Bonding ionic is between cation and ion. Okay, covalent is between non-metal and non-metal, and they share the electron. And metallic is between metal and metal. They have basic attraction is cation delocalized electrons. So comparison of bonding and non-bonding. Where do they have the intermolecular forces? So look at here. For non-bonding, intermolecular. Inter is the dalaman. You have ion and dipole. This is ion, this is dipole. So you have ion dipole charge. For example, Na plus and OH. OH ni ada dipole. Na dia ada ionic. Okay, so that's why. Hydrogen bonding just between hydrogen and others. So biasanya hydrogen and others ni. This is the bonding, hydrogen bonding. Okay, and then polar bond to hydrogen, that's cause a dipole charge. Okay, this is according to electron number of this one, electronegativity of phone, NOF. Alright, so this is the hydrogen bonding that exists. Not here, but between hydrogen and the oxygen. Normally, it's not between hydrogen and others, but between hydrogen and nitrogen, hydrogen and oxygen, or hydrogen and F and fluorine. Okay. Right, so dipole, both have dipole. Then this is also got dipole. So positif jumpa dengan negative charge lah, for example. Okay, dipole. Yang besar jumpa yang kecil yang elektronegatif sini. Jumpa dengan elektropositif sini. Okay, for example this one. ClCl is dipole charge. Alright. Or ion induced dipole. So this is ion. This is dipole. So ion induce the dipole, okay, to polarize electron clouds. Okay, for example, this one ion, and then oxygen. Okay, the dipole, right? And then dipole induced dipole. Okay, this is dipole with the negative dipole, and then induce another dipole. Also can. Dia macam dipole charge juga, but then dipole charge is polarized. Okay, for example, this one HCl and ClCl. So this is just between ICl and ICl. Alright, so you look at this one. Induced dipole induced dipole is this one, produce dipole with the Cl, come back with the Cl. But this one, dipole is the Cl induced with another dipole. Okay, different dipole. Okay, and then dispersion London is polarized electron cloud, negative and positive. For example, they coming from the same one. Okay, the same non-metal and non-metal. So type of intermolecular, we have London dispersion force, dipole, hydrogen bond, and ion dipole. Right. So this one you can read London dispersion force. Okay, polarization. It is which of the electron can be distorted. Large molecule more often polarize more because it has large number and less tightly held. The electron, the magnitude of resulting partial charge is larger. It has larger electron cloud as well. So dipole attraction, this is example of dipole attraction. Either positive, negative mixed together, negative positive mixed together, or positive negative or negative positive is okay as long as they have different dipole moment. Okay, this is amount of dipole attraction. Attraction are maintained longer with the repulsion, get net attraction. Okay, so this is among tumbling molecule lah. is here and there, where positive attract to negative, negative attract to negative, positive, negative, positive, positive also can. Okay. Hydrogen bonding just occur between hydrogen and bond tadi. Okay, electronegative atoms such as oxygen, nitrogen or F. Okay. So we continue with the next slide.